Well, I hope you guys are going to have a good Monday today. When this video releases, it'll be 12:05 on Monday morning. And I just wanted to share a little bit of fun stuff about engines with you. Watch this all the way through to the end if you want to get into the real fun stuff. And I'm going to touch on a few basics to start with. And what we got here is the shaft. You know, you can take a crank when it comes to long and short stroke, engines. If you got a over square would be when the bore is greater than the stroke. The stroke is how far the piston travels, and the bore is how big it is. And whenever you have an under square engine where the stroke is longer than the bore, it doesn't rev up fast, but it's got a lot of torque. But whenever you've got an over square engine, with a shorter stroke and a bigger bore, it revs up really fast, but it doesn't have as much torque. That's just the way it is. You can think of when you're turning a crank to put force on something. If you've got a longer crank, which means a longer stroke, you can put more torque on it. That's pretty easy to understand, actually. So you got the block here. The block is bore for each piston, oil galleries, cooling system, bearing saddles for the crank and camshaft in the block. And of course you have, let me get my pen fired up here. You got your cam bearings in here, and then you got your main bearings in here on that. That's how that basically goes. And this block, whenever they build these things, they got to be line board. Also, when I say line board, that means they got to line this up so that that crankshaft will spin in there nice and freely. But each one of these caps right here is specific to the place it came from. That one obviously is an oil pump mount there. So you don't need to mix any cap up on a head. If you got little camshaft caps, or if you got caps on the block or caps on the pistons, those caps are only supposed to go in one place. So just make sure you keep that in mind whenever you're taking one of these apart and putting them back together. You got these pistons, these particular pistons here, made by Federal Mogul. You're going to have typically you'll have two compression rings, which will be the top two, and the bottom ring will be an oil scraper ring, which is it's an oil ring that's kind of like a squeegee. It squeegees the oil off the cylinder walls where you're not burning a little bit of oil every time the piston goes up and down. But these particular ones here, because of the force that's applied to the piston against the cylinder wall when it's going up and down, they have graphite on the side of them. Of course, they got that fancy little design on them too. But then you got that wrist pin that has to be pressed in there, with a special jig if we're using your press and all. The rings will typically be marked so that you don't put them in upside down, and I'm talking about the compression rings. There's a top ring and there's a second ring. You don't need to mix them up. You need to make sure you're looking at the little dot or whatever on top of the ring to make sure you put them not only right side up, but in the right groove. You got your camshaft here with these egg-shaped lobes that open the valves, and this is how the engine breathes, and the camshaft and the crankshaft have got to be timed together. Earlier lifters, and these would be your lifters right here, but earlier lifters basically were flat on the bottom and rode on the cam, and that had a tendency to wear out, and they got smart later on. These right here would be your push rods on a push rod engine. And they put little steel roller bearings on the bottom of the lifters, and it gave it more longevity, and it reduced, some of the stress and drag and all that, because those can still wear out and everything. And some of the older lifters, sometimes when you were taking apart an engine that had been torn down, a lot of the times the lifter would be flared out a little on the bottom where you couldn't get it out. You're supposed to be able to pull it straight out. On some of the V6 Ford engines, you have to pull the cylinder heads because the cylinder is in the way and you can't even get the lifter out of there. That's another story. And this is how the eggs pretty much line up. You can see this diagram here. You got your amount of lift. There's lift and there's duration. Duration is how wide the top of that thing is, and lift is how far it raises it up. So lift and duration are both an element, plus how that's indexed can be changed on vehicles with variable valve timing for optimum emissions and efficiency and performance. But back in 1984, when I was working at the Lincoln Mercury dealership, there was a Mercury that came in there that was skipping on cylinder number 3, and it was a brand spanking new vehicle right off the truck. And so some of the older mechanics looked it over and checked everything and said, one of them said, well, the only thing that I can come up with that might be wrong with this is it's got a bad camshaft. And I thought, what, brand new engine with a bad camshaft? Well, they gave it to me to swap out the camshaft. And so, of course, to do that, you got to pull the water pump, the timing cover, and the radiator, and all that kind of hogwash. And then you got to pull the intake manifold off, pull all the lifters out. You know, pull. I mean, you don't have to pull the heads, but you got to pull the valve covers because you got to pull the rocker arms, the push rods. The lifters have got to come out, and the distributor's got to come out because it's got a gear that's connected to the camshaft. Pull that camshaft out of there, laid it on the bench. They ordered me a perfect circle camshaft that from the parts store. And I laid those two camshafts side by side on the bench. I could not see anything different in any way, shape, or form, no matter how I measured, as far as what might be wrong with that new camshaft. And I didn't know if replacing that camshaft was going to fix that number 3 cylinder misfire or not, but I was just following orders. And I put that thing all back together with that perfect circle camshaft, and it ran like a brand new car, like it was supposed to. But with the camshaft that came in it, it wouldn't run without skipping on cylinder number 3. That's the only time I've ever seen that. You typically won't see it unless it's on a brand spanking new vehicle that hadn't quite been built, you know, where the engine wasn't quite built right. Valve timing. Now this one right here, you got a belt. Belt's pretty cool because you basically put seals around the shafts and you snake the belt around the sprockets and everything, and it's out here. It doesn't even need to be lubricated. Now there are some engines that have timing belts that run lubricated. Those are kind of rare. You can look that up, but there are some that have sealed chambers with where the belt is actually running in lubricant, in oil. But the chains have been around for a long time. Even back in the early 80s, some of your Asian pickup trucks had timing chains. And so that was something that we used to have to deal with back then. Overhead cam, you know, with timing chains, and back in the early 80 Mazdas, and some of the other ones too. But this one here, you might notice, has got variable valve timing because you can see how the center of this thing is connected to the camshaft, and the outer part of it is driven by a chain. And oil is pumped into these chambers here to change this back and forth, and it slightly indexes, re-indexes, and changes the indexing between the gear and the camshaft to change the opening time on the valves and whatnot. Now your heads and your valves, heads have a whole bunch of different looks, but most of them got the same job. Remember now, when you've got overhead cam, you're going to have a pressurized oil feed going up through the cylinder head gasket into the head to all the camshafts where they spin in their saddles, because if you didn't have that, they wouldn't last very long. These kind here on the old V8s, they just basically have splash oil, and they'll have oil pumped up through the push rods. It goes through a little hole into and gets puddled in the rocker arm so that it's properly lubricated all the time while it's working. And so that oil has got to drain back down into the block whenever everything is over with. And if it gets sludged up and it clogs up the oil drain backs down in here on each end of that head where the oil can't go back down in the block, you'll have a valve cover that's got a whole bunch of oil trapped in it. And furthermore, somebody will think it's low on oil when it's really not, and they'll wind up with too much oil in it. This one lady brought her Buick to me, and she was in her 40s, and it's pretty sharp, I thought. But she brought her Buick to me, and she said that it was smoking or something. I can't remember what the symptom was, but she said she added oil to it. And what I found out was she just poured oil in it until she could see it coming up in the oil filler. I thought, somebody surely taught this lady about a dipstick at some point or another where you could see how much oil was in the crankcase. We had to drain a bunch of oil out of that one. There was another time whenever the oil dispensing system at the dealership malfunctioned, and somebody wound up accidentally putting 8 quarts of oil in a 5-quart crankcase in a Ranger. And they gave it to me because it had an engine vibration. It was just shaking. And whenever I checked the oil, it was so far up the stick, I drained it down to where it only had 5 quarts in it, and all that vibration was gone. So, you're not always going to have the same symptoms. There was this other lady that I knew that her car would labor knock a little bit and boil out a bunch of white smoke periodically. And I checked it, and it was way over full on oil. And she said the guy at the gas station, when she gassed it up, and told her she needed oil and kept pouring oil in there that she didn't need. I guess he figured too much was better than not enough. I don't know. All right, so we're going to build an old school V8 right quick. There's your crankshaft. Now we already put the rods on it. That's not how you'd really build it. And right here we got your valves. And you got an intake manifold, plenum chamber, exhaust manifold, there's water pump and all that. That's a pretty quick little thing. And here's a more modern 4-cylinder. It's these more modern engines are more complicated than the older ones. They got more stuff to put on them and more moving parts, and you know, the timing is different and all that. A lot of these engines don't even have timing marks on the cam and crank. You just have to line up, you know, some notches and put a peg in there or something to put it in time, and that's becoming fairly common. As a matter of fact, starting in '97, the Explorer 4-liter was like that. You had to have special tools to put it in time because there wasn't a mark anywhere. And that's kind of annoying for the people that have done old school stuff. Let's see how this thing works on the inside. See, you can see the valves working, and this is very accurate. All right, so you got your compression, fuel, and ignition. Oxygen and the hydrocarbons ignite under ignition, and they create a really over 2,000 degrees in the combustion chamber. That heats up the nitrogen, which is 78% of what's going in there, and the nitrogen expands and pushes the piston down, and that provides the power needed to turn the crankshaft, and that drives the flywheel, which is bolted to the torque converter, which goes to the input shaft in the transmission, which goes out to your wheels in your final drive. But you can see that fuel going in, squeezing, it's got a compression, and that's intake, compression, power, and exhaust. Intake, compression, power, exhaust. See how that works? That's pretty smooth, isn't it? All right, fuel and ignition timing. When a fuel-injected engine is starting, the injectors will double pulse. On the old carburetors, you used to have to pat the gas and use the accelerator pump to squirt a little bit of gas in there, and you close the choke at the same time. And on a fuel-injected engine, when you're spinning it over, all the injectors are squirting together. Now, some of the Asian cars had a cold start injector, and that's the only time I'd ever put fuel in there was whenever you were first starting it, and it would be mounted on the manifold. But typically, everybody got smart and started pulsing all the injectors together, and then they would follow the firing order after the engine started up, which is a pretty smooth way of doing it, actually. But the point is, an engine still needs the same thing it always needed. Even when it had carburetor, it's got fuel injection, it still needs the same thing if it's an internal combustion engine. But whenever it's not loaded at idle, the ignition timing hovers around 10 to 15 degrees. If you raise the engine speed while you're checking it with the timing lights, you'll notice the timing advances. And the reason for that is because since the piston's moving faster and the gas only burns at one speed, it has to get it spark quicker so that the maximum pressure increase will be happening at the right time to drive that piston. And so your ignition timing advances too. There's various different things ignition timing does. I don't want to go into all of that right now. But you might notice after the spark happens, the pressure really increases in the cylinder, then it drops off as it pushes the cylinder back down. We've looked at these cylinder waveforms before, but this is drawn a slightly different way, and this shows you where the piston is. Now on the road, when you're accelerating or pulling, the timing retards to prevent detonation. The detonation is an uncontrolled firing event whenever the gas lights off too soon while the piston is still coming up, and it's like hitting the piston with a hammer that even makes some noise like that. People call that valve rattle, but that's not what it is. If you advance the timing too far with a distributor, you can get this, or if you got combustion chamber deposits like heavy carbon in there that's taking up some of the room and increasing the compression, because it's taking up some of the room in there, it can cause it to, the mix when the engine's good and hot, the mix can light off before the spark plug ever fires. And so it begins a combustion event too early, and it actually reacts. The piston's not going to stop unless it's something solid, but it does ring it like a bell when that flame front comes together and hits it. That was happening a lot sooner than it was supposed to. Ignition timing that's advanced too much for your with your distributor will also cause it to kick back, and it can cause it to buck and surge going down the road, but mostly you'll notice labor knocking and notice a kickback when you're starting. And what I used to do when I was working on one out there, working on a boat engine or something, and didn't have a timing light, if I was going to set the timing so it would have maximum power using a distributor, I would hold it up about 2,000 RPM. I learned this from my dad, and advance the timing until it started to pop and snort and cut up, and then I'd go back until it sounded really good, and then I'd lock it down, and you got the timing right where it needs to be, as long as it's not kicking back or labor knocking, because you want the timing to be just as fast as you can bring it until right before it labor knocks. You see, of course your EGR is supposed to pump, lets about 5% of your exhaust gas back in there to. It makes put inert gas going in there, cools the combustion chamber, and helps it run cooler so it doesn't make oxides of nitrogen, but that's another story too. If you know the firing order, you can figure out companion cylinders by drawing an imaginary distributor cap. If the firing order is 187265543, then basically you'll know that, and you draw on your little, you know that 1 and 6 are companions, 8 and 5, 7 and 4, 2 and 3. You can figure out your companions. Why are the companions important? Well, whenever you're wanting to find top dead center on one that doesn't have any compression, you can find top dead center on the companion that does have compression, and then turn the crankshaft the proper number of degrees for the number of cylinders it has, and then you have got your cylinder that you're interested in testing on top dead center, even though it may not have compression. If it doesn't have compression, it's very difficult to tell when it's on top dead center and both of the valves are supposed to be closed, and we talked about that a little on a previous video. But you can also figure out the companion cylinders by dividing the firing order in half. If it's 187265543, then you can break it in half like that and go A, B, C, D. So A, both of them that are marked A are going to be companions. B, C, and D. See, that's not really complicated there at all. So your degrees between firing events is pretty important. 720 degrees is 2 full crankshafts. So if you got a 4-stroke, piston's got to go up and down twice, so that's 2 full crankshaft revolutions. So you divide that by the number of cylinders. 720 by 8 is 90 degrees, 720 by 6 is 120, 720 by 4 is 180, and any number of cylinders you can figure this out. Alright, a sealed chamber, loss of compression can be turned, if the valves are closed and the rings are sealed and the piston doesn't have a hole in it, you should have very little leakage. But you can, when you get it on top dead center, just put some air in there. Don't put a lot of air in there, just a little bit. And, like 15, 20 pounds or whatever of pressure, and listen for it to see where it's coming out. And that'll give you an idea of where the problem is where that cylinder's been compromised and is losing air. What we also used to do was stop up the PCV and put about 15 pounds of air pressure on the crankcase to find engine oil leaks. Now that's splash oil leaks, that's not pressure oil leaks. For the pressure oil leaks, you can actually put higher air pressure on the, pull the oil sending unit out and put pressure in the oil gallery and, listen for where it hisses out or see if you got any pressure leaks that way. That's just a little quickie there. I don't charge any extra for that. Now we pulled all the plugs out of this cylinder on this Taurus that had a misfire, and the compression was making its way, making sure companion 5 was on exhaust, because we didn't have any compression at all on number 1. So we put 5 on exhaust stroke, by turning it 120 degrees. In other words, we found the companion cylinder the way I was talking to before. Alright, and so we made sure we had number 1 on TDC compression in spite of the fact that it had no compression at all. We injected smoke into the number 1 spark plug hole, and it came out the number 3 spark plug hole. Now the engine's just sitting here static, but we know for a fact, because of all of the careful preparation we've done, that number 1 cylinder is on top dead center, and both of the valves are supposed to be closed if everything like it's supposed to be. But since there was no compression on that cylinder, we knew there was a problem there. And so what did that mean? Okay, so you got to know the firing order. you got to know what stroke number 3 is on when number 1 is at TDC compression. So because smoke was coming from number 3, so we're thinking, well, where is number 3 cylinder, and which valve is open on number 3 when it's at the place that it is. All right, so number 3's firing event happens 2 cylinders before number 1, so the crank had to be turned, so the crank had turned 240 degrees, you know, after, you know, while the, in other words, 240 degrees after top dead center on number 1 was where number 3 is. And so number 3, it turned out, was losing its smoke, right? And so, in other words, the smoke that was going in number 1 was making its way somewhere and going out number 3, and that told us that number 3 exhaust valve was open, so the number 1 exhaust valve was compromised. See, the number 3 exhaust valve was like it was supposed to be. Number 1 exhaust valve shouldn't be letting any smoke into that exhaust system so that it could go over there, because we had all the plugs out, you see, and we just looked for where the smoke came out. That worked pretty good. Well, this 88 Honda CRV, this guy crashed it really bad, and he bought a good CRX with a bad engine, so we were supposed to take the good engine and put it in the uncrashed car. All right, so the surprise, I said, while we got this thing in here, guys, let's go ahead and check the compression. We did, because you could tell it was going on. You know, it sounded fairly, you know, but you could tell there was a little bit less compression on number 4. And so we went ahead and did a compression cylinder leakage test. All right, but it sounded fairly normal for the most part. It picked up speed on 1 compression stroke. We did a cylinder leakage test on the cylinder that had no compression, which was number 4, and we found out, and it didn't have any cylinder leakage at all. So how is it that a cylinder can have no cylinder leakage but not have any compression either? Well, what we found out when we pulled the motor out was somebody had been driving this thing too hard. It had thrown a rod, it knocked a hole in the side of the block. The piece of the rod that was, you know, there was a piece of the rod that was busted off of there by the crankshaft spinning so hard and so fast, and the piston just stopped right in the bottom of the cylinder, and that's where it stayed. So you had good valves, the rings were sealing, but the piston wasn't moving. Since the piston wasn't moving, it had no compression, but since the rings were sealing good and the valves were closed, it didn't have any cylinder leakage either. And so that solved that mystery. There wasn't any gremlins or ghosts there. It was just something that you wouldn't ordinarily think about, that rod coming loose from the crankshaft, getting broken off, getting knocked out a hole in the block and being on the highway somewhere. Ordinarily, when one throws a rod, you hear it knocking, and that's as far as it goes. Well, this thing had 2 different fuel injections. One of them had multi-point fuel injection, and the other one had throttle body injection. And so I told my students, I said, whoops, we got 2 different kinds of fuel injection systems. What do we need to do here? And they basically, one of them said, oh, we got to tow the engine controller and all the wire harnesses out and all that. And I said, no. Now this one here that was in the car, that was in the good car that he brought us, was a 1.5. This was a 1.6. But you couldn't look at the 2 blocks and tell any difference. What we did was, you got a short block versus a long block. You got to know the difference between those 2. This one guy was talking about, he didn't know anything about vehicles, but he was going to buy an engine for his wife's van, and he went in the parts room and they says, do you own a long block or a short block? And he came and asked me, he says, well, me and the truck mechanic were talking, and he says, can you come out here and look at my wife's van and tell me if it has a long block or a short block in it, because they're asking me this question and I don't know how to answer it. And the truck mechanic looked at me and says, I'm going to let you handle this one, and he just walked away. But anyway, the difference between a long block's got the head and usually the pan on it, sometimes the valve covers, and the short block will be just the block with the rotating assembly with the pistons in it and all that, you know. So, and it won't typically have the camshaft unless it's a cam in the block engine like an old V8, if you get a short block for one of those. But you're going to have your head, see that one there's got the camshaft in the block. Even though it's a short block, you got the camshaft. But if it's not overhead cam, if it's overhead cam, you won't have the camshaft in there. But the long block is typically going to have the heads on it and all that. Oh, with a short block, you'd actually get your heads reworked and get them put back on there. Save a little bit of money that way, But most of the time, if I'm going to go that far, I'm typically going to put a crate engine in it anyway. Well, the best and smartest way was what we did. We took our throttle body injection bad engine from the good car, and see, that was the car we were going to wind up, he's going to drive out of there on. We pulled that TBI engine out as a short block. I'm sorry, as a long block. And then we took the long block from the other car and dropped it in there, and then we bolted up the manifolds to that one, and we had it was a sort of a sleeper, I guess you'd call it, because it had throttle body injection on it still, but it had the 1.6 liter long block in it, so it had a slightly larger engine than what it came with. But anyway, that guy's really happy. I think his bill was about $400 because we didn't charge labor at the school and all. That was a really instructional job for the guys, though. Well, I hope you guys have a good week. And once again, let's all be careful out there.